So, guys, the good news for you. Good news for you with organic and nuclear, like I said for the past few days. These last two subjects, why we do them a little bit quicker and why we're not having a test on is because it's all in the reference packet. So we've seen this is now the third table in your reference packet that's purely devoted to organic chemistry. We've had the one with the prefixes. We had the alkane, alkyne series, which is table, so first one's table P, then table Q, this is table R, showing the functional groups. Okay? So in organic chemistry, you have all these different classes of compounds, and they are classified based on their quote-unquote family or functional group. So we go take a look through this list. We have the halides, which are just halocarbons. What do you think they have in them? Okay, which are halogens. What group is the halogens? 17. So it's got your fluorine, chlorine, bromine, and iodine. Now notice, how you name those in an organic compound, guys, is fluoro, chloro, bromo, and iodo. X represents any halogen. So notice, guys, down here at the bottom of table R, it says that R represents a bonded atom or group of atoms. So R is where you would, in all of these, is where you would have a longer chain of something. Carbon compounds. So you have something like an alkane, and then this part would be added in there. Okay, this functional group piece. So the halides include those halogens, those four. So an example, and again, you are given an example of each functional group, showing what their formula is, how you name them, so that if you have to name things on your Regents exam, you have a reference to look back at. So in this case, much like we did with the alkanes, or excuse me, the alkenes and the alkynes, guys, where we counted the number of carbons, you can see the same thing. This is called 2-chloropropane. So prop is your long chain that you would start with if you had to draw it out, and then 2 tells you where that chlorine is hanging off of, which carbon it's hanging off of. So we're going to do a lot of practice with this after we go through the functional groups. So it's the same process that we just learned, except now instead of using a double bond or a triple bond, we're throwing in a functional group. Okay? They each have special names within those. The next class of compound is an alcohol. Alcohols, guys, have OH at the end, all right, or hanging off. So a general formula right here would be R-OH. So right here, we can identify an alcohol based on O. There's an OH at the end of the formula. Okay? So in this case, it would be 1-propanol. So we change the N now with these, with all of the rest of these, or most of these, we change their name at the end to signify their functional group. So if it ends in OL, it's an alcohol. Okay, it's got that OH at the end. The next one is an ether. You've heard of ether before, right? It's the stuff they use in like movies and stuff to knock people out. They'll put it in like a rag. They'll put it to their nose and it makes people fall asleep. All right, chloroform. Yeah, it's just an ether. Okay. So an ether, guys, it has R groups on both sides, so you've got an oxygen in the middle. So this would be like methyl, ethyl, ether. Ether meaning the oxygen's in the middle. On one side, you have a methyl group. On the other side, you have an ethyl group. Okay? So again, using our prefixes, kind of signifying it and building out from the functional group. The next one is an aldehyde. You've heard of formaldehyde? What do they use formaldehyde in? Really? So, preservation, dead people, formaldehyde. Have you guys ever dissected anything?
You guys ever died before?
No, I didn't say that. Have you ever dissected anything? Like you guys ever did a dissection? Have you ever died? All right. So guys, an aldehyde. Take a look though here. Okay. Here's what this functional group looks like. It's a carbon at the end, but then it's got a double bond oxygen. Shh, focus. It's got a double bond oxygen, but then an H sticking off of it. So this is a terminal. What do I mean by terminal group, guys? What's terminal mean? Alex? Yeah, it's at the end. Okay, it's at the end, only in one place. So an aldehyde has to be on the end of your chain. So in the name, it would come at the end of that. All right, the end of your structure, you could draw it like this, or it could also be written out in your formula, guys, like this. It could be CH3, CH2, COH. Okay? Actually, no, you wouldn't write it like that because then you would think it's an alcohol. It's going to show you like it shows you right here. Keep it simple. Okay? But notice the name, it's going to sound like an alcohol. Propanol, this is propanal. Al is the end piece there. So if you have an Al at the end, it's an aldehyde. All right, see how I did that? Al at the end, it's an aldehyde. Okay? Next one is a ketone. Notice how these are all similar to each other. Okay? A lot of them as we go down, guys, they have double bonded oxygens. That's unique in organic chemistry. So a ketone is the next one. Notice it's very similar to this aldehyde, except now instead of an H on the right, what does it have? Other carbons. Okay? So a ketone is going to have this double bonded oxygen, and it's going to have carbons on both sides of it. All right, so this would be 2-pentanone. So notice what we do here with the end of a ketone. It ends with that -one suffix. Okay? So you can see a double bonded oxygen in the middle of your compound surrounded by other carbons. Or an organic acid, very similar. Double bonded oxygen, but then there's got an OH hanging off of it. So again, this is a terminal one as well, like an aldehyde. How they differ is that instead of just having an H like aldehyde, it's got an OH hanging off of it. So this is where you get like something like it's going to end with the name acid. Propanoic acid, ethanoic acid, methanoic acid. So it ends with this oic acid piece. An ester. So you've got an ester and you've got an ether. I'll tell you the way to remember that in a second. An ester, similar to an organic acid, except now, instead of an OH hanging off, it's got O connected to another carbon. So you've got all these O's in the middle. Methylpropanoate. There's your ending for an ester, O8. An amine has got a nitrogen in it. That one is the first one that's different. Okay? It's got a nitrogen somewhere in there, and it's surrounded by other carbons. So it actually ends with that term amine at the end of it. And then an amide has got an oxygen in there. Okay? And then you've got your nitrogen group hanging off it, and it ends with amide. So guys, I know this is very confusing. The big thing that you're going to have to do is to use this reference table to identify what it is. Now, the way to remember the difference between an ether and an ester, I still remember this from 12 years ago when I learned it when I was in high school. My teacher said this. You have the ether bunny lays ester eggs. Super corny, right? Super cheesy. But take a look, guys. An ether has got like ears all around it, like it's a bunny. Okay, if you were to draw it out, it's how you can remember the difference. An ester has got multiple oxygens in there, so it's like they're eggs within the compound. Okay, the ether bunny lays ester eggs. That can be a way to help you. I know it's corny, I know it's cheesy, but if it helps you identify, because you're going to have to identify different functional groups. What they throw at you, I don't know. But you've got this whole table to use it. Let's take a look and do some practice here together. All right, we're going to start off with the halide group. Okay, 3-bromopentane. If we have to draw this structure out from given the name, what are we going to start by drawing first? The long chain. So what's my long chain? Pentane. Is that an alkane, an alkene, or an alkyne? Okay. How do you know it's an alkane? A-N-E, right? Does that mean it has double, single, or triple bonds in it? Single. All single. So pentane is 5, like Maddie said. Okay. Now what's the next part of drawing my structure? The bromine, right? We're going to see where that bromine is going to hang off. How do I figure that out? 3, right? So count over 1, 2, 3. Go up. It's going to be a bromine. And then what's everything else going to be? Hydrogen's hanging off of there. Simple, right? Not much different than the alkanes. Except now, bromine. Bromine's in there. Let's take a look at this structure that we're given, and we've got to name this. How do we go about naming a compound? What's the first step always? The longest chain. Number of carbons. What's that long chain going to be? What'd you say, Maddie? Butane. Okay, so it's something butane. Now, what's hanging off of it? Fluorine and chlorine. Which one do you think you want to name first? Why fluorine? Well, if I start from the right side, chlorine comes first. Why would we want to start with fluorine first? There's another reason.
It's higher up on the group 17.
It's higher up in the group 17. Why? Because it has more... No. What'd you say? Electronegativity. Okay? So, start with fluorine first, higher electronegativity. What is that one on? What carbon is fluorine on? So it's 2 what? What are we going to call that? Fluoro. 3 chloro butane. That's what it would be. I know it's not all in one line, but that's what it would be, guys. 2 fluoro, 3 chloro butane. Make sense? Take it piece by piece. Tomorrow we're going to practice naming all day. We're trying to go through these today. I've got some basic practice for you guys for homework. So once we get through these examples, then we will we'll get into some practice with the functional groups tomorrow, as well as talking about the 7 types of reactions. All right, moving on. Alcohol. Okay. 2-pentanol. What are we going to start with? 5 C's. Because why, Hunter? Pent. Right? Penta is 5. So start with your 5 C's. Now the 2, what's going to be hanging off of the second carbon? Why OH, Zach?
Because it's alcohol.
Yep. Now, if we weren't given this, that it said an alcohol here, how would we know by the name that it's an alcohol? The OL. Okay, and that's where using table R comes in handy, guys. So it's 2, and we got to draw an OH there, and then it's just hydrogens all around. Hydrogens all around. Hydrogens all around. No. How are we going to name this other compound? Why? Absolutely, guys. Ethanol. That's it. We don't have to tell what number it is. You could say 1 ethanol, but ethanol, guys, only has one possibility for where that OH could be. It's always going to be on that first carbon. Okay? Questions? If I'm going too fast, let me know. Ether. What was the saying? To help you remember what it is? Ether bunny. So that means you've got the oxygen in the middle. Okay? Again, look on table R, guys. It tells you what it is. So you see dimethyl ether. This one's a little bit different. What do we have to start with the ether functional group to build off of? Oxygen, guys. Your oxygen piece is what you're going to start with. Then your other chains are going to be based off of that. So we're going to have oxygen in the middle. We've got to figure out what our branches are going to be. What are they going to be here? What's that? Speak up. Yeah. But now it says dimethyl. Di means how many? 2. So you have 2 methyl groups hanging off. So you're going to have 1 carbon on each side, like that. Okay? Don't forget your basic chemistry, guys. I know this is something brand new and we're naming it and all that stuff, but you know what that prefix di or tri or whatever means. Okay? Don't forget your basic pieces. How are we going to name this one? All right, it ends in ether. So then isolate your 2 groups. Which do you think is going to come first? Do you think it really matters here, though? You could start with the smaller one, guys. It's not going to matter because one's off one side, the other's off the other side. Ethyl, propyl, ether. Ethyl, propyl, ether. Right? Because that ethyl shows you the 2-chain carbon hanging off, and then the propyl shows you the 3-chain carbon hanging off. All right, aldehyde. We are given the term butanal. But means what? 2? But? 4. All right, so guys, look on table R. Al means Aldehyde. Okay, so what's an aldehyde? Oh, it's this piece right here hanging off. Now, is it terminal or is it within? It's terminal because it ends with the H on the end. So you know that your last carbon is going to have this functional group hanging off it. It's going to have a double bonded oxygen with a hydrogen. So when we go back and take a look over here, does it matter which end I put it on? No, it doesn't. I'm just going to do it right here. Just to be a little bit different to show you that, hey, this is still the same thing. And then what do I have to do with all my other carbons? Yeah, absolutely. Okay. Why won't this guy have another hydrogen on it? It's already 4 bonds. Okay. So you got to keep the basics, guys. That's the thing you got to remember. Each carbon can have 4 bonds. Use table R to identify your functional groups. Okay. Ketone. How do we identify? If I didn't tell you this was a ketone here, how would you identify that it's a ketone? Right, it ends with "-one" or 1 at the end. So now if you go to table R, let's see it. Is a ketone terminal or within? Within. So you know that you're going to have a long chain of carbons, and then you'll identify, based on a number, where you're putting that double bond oxygen. So if I go back to my example, prop means 3. Remember, guys, don't guess. Use table P. It tells you what it is. So it's C. 3 C's. 2, right in the middle. That's where, with a ketone, that's where your double bond oxygen is going to go. And then, what's going to go around my other carbons? Hydrogens. Just like that.
This seems really hard to mess up.
Because of what they give you, yes. Think about having to memorize it all. That's what makes organic chemistry so complex, is because you don't always have a reference material when you're taking those tests in college. But yes, this, guys, they make it. New York State writes it so that you can't really mess up the organic stuff unless you're completely not trying to use the materials given to you. That's why I'm trying to teach you to use those materials only, and we're not worrying about all the rest of the stuff. What would we name this guy? What's our long carbon chain? Bute. So we're going to call it what? Butanone. Or butone. I think you would get credit for either of those, to be honest, at this level. Butone. Propanone. No, I think it would be butanone. That's what you'd want to call it, not butone. But I think you'd probably get credit for. I would give you credit for either. I'll look into to see what what they would do on the Regents exam. What else am I missing though? 2, to signify where that double bond oxygen is. Organic acid. Take a look on table R. If we have an acid, is that terminal or within? It's terminal. So that means this whole big functional group, guys, is coming on the end of whatever it is. So draw your chain first, and then put that piece, that functional group, on the end. Well, methanoic acid is how many carbons? 1. So you just have 1, and you're just going to attach the acid piece to it. What else do I have to do here, though, to finish this structure? 1H, yep. Because remember, the double check, guys, when you get done drawing, that each one of your carbons has 4 bonds with it. It's got to have 4 bonds. What are we going to call this other one? Ethanoic acid. Is that the example that they give you on table R? What example? They give you propanoic acid?
Yeah.
Okay. Hey, if you get lucky, guys, on your Regents exam, and they give you that one, go right there and use it. That's even easier. That should be a gimme point. Ester. Again, not another old lady. You got Ethel and Ester in this unit. Ester, the ether bunny lays Ester eggs. But again, you're not going to be given, guys, that I'm giving you this here, that it says Ester. How do you identify it? 08. 08 at the end. So if we go back and take a look at our functional group for an ester, is this terminal or is it within? It's within. So you're going to have to do a little bit more work. Okay? We have ethyl propanoate. So ethyl means how many? 2. Prop means you're going to have 2 parts hanging off of this. So start with all the ones that go within. That's the way you want to start as your building block. So for an ester, it's a carbon, double bonded oxygen with another oxygen. Now you can start building off of that. Doesn't matter which side they come off of. No, typically on the left, I'm going to put my first one. Ethyl has 2 carbons. Put my hydrogens around it. Prop has how many? 3. So make your 3 come off. There's your ethyl propanoate. Up there in the picture, what would we call that one? How many do we have here with this? Okay, that's what would we call that? Propyl. And then over here we'd have ethanoate. Propyl ethanoate. So I believe, and I'll do some more research on this, guys, as we were doing this one. Notice how these are similar? I believe that it does matter the order that you put your side groups when you have a terminal one. I'm sorry, an internal one. That the one that comes first. So notice how ethyl came first here. We put it on the left side, and then propanoate came on the right, and this one's kind of flipped around. All right, so that makes this one propyl and then ethanoate. I believe that that's how you've got to do it. If I remember, I'm going to do some more research to refresh my mind, my memory with that. All right. And then just a couple more. Amine, butanamine. But means what? 4. So is an amine terminal or within?
Within.
Okay. Let's take a look here. So it's within. Now, what do you think that 1 is telling us? Yeah, it's connected to which carbon? The amine part, guys, the nitrogen, that's telling you what carbon it's connected to. So how many electrons will be hanging off of when you take a look at your reference packet for the amine? Oh, I'm sorry, I was looking at the amide. My apologies. Take a look here, guys, with the amine. How many R's do you have there? 3, right? So you could have up to 3 different chains coming off of it. At this level, what they're probably going to give you, like this says propanamine over here, okay, because it's 1, it's hanging off. You're going to assume that hydrogens are hanging off of this. Okay, you're just going to put hydrogens. It could be other carbon chains that could be attached to this amine, but we're going to keep it simple and make sure that it's hydrogens hanging off of it. I don't anticipate, or I couldn't imagine them giving you something crazier. So then this is just going to be, you could write it as H2, okay, or you could draw it out and then H's all around. Okay, nitrogen is one, guys, that will have 3 things hanging off of it. Okay, not 4. Carbon is the only one that has 4, so keep that in mind. Like this example up here, where there's only 2 hydrogens hanging off of this. So what's our long carbon chain? 2, which is going to be what? It's our prefix for 2. We're almost done, guys. Ethanamine is what you should have. Ethanamine. Ethanamine. And the last functional group, guys, is the amide. So pentamide, 1 pentaminide. Oh my goodness. Pentanamide, yeah. 1, 2, 3, 4, 5. And your nitrogen's going to hang off of it with hydrogens right there. And all your carbons have them as well. Okay. Count them up. 1, 2, 3, 4. I am missing my oxygen, aren't I? Right here, which makes this, I was thinking it's an amine. See how easy it is? An amide changes, guys, you got that double bonded oxygen. Okay? So up here, the other one is going to be what? 1 butanamide. Get some weird names going on. Okay? Questions? Basically, guys, isomers, same formulas, different structures. They've got the same number of atoms, they just are drawn different ways. Bigger molecules do have more isotopes because they have more arrangement possibilities.